you have a ketone, then you have a grignard. So if I ask you what would happen to this reaction, many of you say that, oh, grignard is going to make an attack to carbonyl, that push electrons up, so you get a coupling groups there, that gets protonated in the end, it becomes an alcohol. Just like that. It's a very simple mechanism that you learn from the chapter 10, and then you're very proud that, oh, I keep figuring this thing out. Then I'm going to say, no, this thing's going to not happen. Why it does not happen? The grignard reagent is a nucleophile. At the same time, it is a very strong base. If you have an acidic proton in the molecule, then you basically, the grignard is not going to go after the carbonyl, it's actually going after the acidic proton right there. So that proton is acidic enough. So the grignards go after this, and you get an alkoxide form, and the grignard just becomes a base, and once it gets protonated, it's dead. So that's the thing. When you're doing a grignard reactions, you cannot have an acidic proton in the molecule. Acidic proton means anything acidic than the grignard. The thing is that grignards are so basic, everything else becomes acidic. So these things are not allowed. You've got NH, that's not allowed. You've got even acetylene groups, the triple bond with the hydrogen there, that's not even allowed. So many hydrogens are not allowed there. So that's the trouble. You cannot do this reaction because your reagent is going to be killed. Then what do you do? The solution is simple. If you don't have that proton, everything's fine. Only trouble happens because of the acidic proton there. So what you can think about is just get rid of that proton. Just get rid of it. If you don't have that, then the grignard is going to go after this carbonyl. Then this thing forms. After protonation of that, you get an alcohol. So the question is, how can you get rid of that hydrogen from the alcohol? So that's the thing. That's the way the Silyl ether becomes useful. So Silyl ethers can be formed like a silicon is a Silyl chloride. These can be alkyl chains, 3 alkyl chains there. It could be methyl groups there. It could be ethyl. People sometimes put the butyl groups. These are isopropyl groups. You can put so many different things. But the Silyl chloride reacting with an alcohol is basically this falls out and then comes in. It can substitution reaction. Then you can have a silicon bound to the oxygen, and that's Silyl ether. It had a hydrogen, acidic hydrogen before, but after it becomes a Silyl ether, that acidic hydrogen is not there anymore. So that's the way to get rid of the acidic hydrogen. You can do a grignard reaction. So that's the reason why we call the Silyl ether as the protecting groups, alcohol protecting groups. It protects an alcohol. Anyway, so this is a tri-isopropyl. We got 3 isopropyl. Tri-isopropyl Silyl groups. So it's called KISS. So different alkyl chains with different names, sometimes PMS, 3 methyl groups, trimethyl Silyl is possible. Sometimes TBDMS is a long name. Tertiary butyl, dimethyl Silyl. There's so many things, variants available. But these particular ones are something called tri-isopropyl Silyl. Tips. Very common protecting group we use. When you have an alcohol, just treat the Silyl, the TIPS chloride, and then you get the alcohol becomes a Silyl ethers. Then basically you can go for the same reaction we talked about. As we talked about, if you have that acidic hydrogen there, the grignard is going to be killed right away. It's not going to happen. Grignard is going after the proton, it becomes a methane. You can see the methane gas bubbling out. But grignard is dead, so no reactions. So what is a remedy? What you can do for the reaction? You make it alcohol as a Silyl ether. That's the value of the Silyl ethers. The TIPS chloride, now it's going to be replace the hydrogen there. So you're going to have a TIPS Silyl ethers. Then it doesn't have a no acidic hydrogen. So if you're using a grignard, then grignard is basically going to go after these hydrogen positions and then make it there. And the second step, protonate. So you get this done. So we got the product done. Only problem is we have to get rid of that silicon. You break the Silyl oxygen bond. That happened to be very simple. All we need to do, adding fluoride ion. Fluoride ion, somehow the fluorine really loves silicon. When they see it, they just have to go there and bound it. So fluoride, go to the silicon, that's going to release an oxygen out, so you get the alcohol there. So you can use a fluoride ion like a sodium fluoride, but sometimes if you want to make it organic solvent soluble, because those are salt. If you treat the sodium fluoride, that is a salt. Most of the time, you cannot dissolve in organic solvents. So we want to make it, we want to put a big cation, alkyl cation into something called the tetrabutyl ammonium. So that makes a cation pretty big in organic structures. So these things can be soluble in organic solvents. So that's why we often use this. It's something called the TBAF, tetrabutyl ammonium fluoride. But one of the things organic chemists do a lot, they use a lot of acronyms. So all the name of the meat is so long, you cannot just spec only that this, does that. So we use a lot of acronyms. So TBAF is basically just a fluoride ion, comes with a big alkyl cation. And then these things, yeah, who want to say the trihydrogen because it all the time, so we put tips. It's so simple. So it becomes like a second language to you, right? So sometimes people say, oh, I put the tips on there, and I get it TBAF. That's why it's very hard to follow unless you know the jargon of the chemistry. But now you know it. Anyway, you can see how this goes. That becomes a problem. So you cannot use a Grignard to this molecule directly. So what you do, you protect the alcohol by converting it as acyl ethers. When it becomes acyl ethers, now the trouble is gone. So you can carry out the reaction that you wanted to do, but you have to get rid of it. So this is the removal of the protecting part. That can be done by just adding fluoride as a part of TBAF. Then you get the products. So this is a strategy called the protecting group strategies. When some of the functional groups gets in the way of the reaction, you basically mask it, then you do whatever you want to do, and then you release it. This is the first time we introduce this concept of protecting group strategy to you, but all the time, you're going to be introduce more protecting groups, so we can actually carry out more difficult synthesis. So in the end, you can actually make organic molecules, many steps after, you can make this very interesting organic